Okay, so in this video we are going to be talking about collinear points. Okay, collinear points. Now, what are collinear points? That's the first question that we're going to start asking ourselves. These are three or more points. These are three or more points. Three or more points that lie in the same line. Okay, that lie in the same line. This is how you can define collinear points. These are three or more points that lie in the same line. So what is the concept that we use normally to determine if three or more points or two or more points are collinear and like that? What concepts do we actually put into consideration? One thing that you need to understand is that whether a line is increasing or rising, or if it's dropping, one thing that you need to understand is that the gradient is always the same. The gradient or the slope is always the same. Is always the same. But this is not the case when you're talking about caves. The gradient of a cave is not fixed. Okay, so maybe if you're having point A, point B, point C here, the gradient of this cave at these three different points is going to be different. But if you're talking about the line, if maybe this is your point A, this is your point B, this is your point C, the gradient on each of these lines is going to be the same. So the gradient of the line is always the same, or the gradient of the line is always constant. That's the concept that is behind us determining if three or more points are collinear. So how can we now handle that? How can we now deal with that? So let us imagine we are having point A. Point A is -1, -1. Point B is 0,1. And point C, let us imagine point C is 2,5. And then a problem has been given for us to determine the gradient, or rather to determine if these points are collinear or not. So the concept behind it is this one. If these 3 points are the same or are on the same line, if they are collinear, then what you need to understand is that the gradient of AB should be equal to the gradient of BC. And this should also be equal to the gradient of AC. The gradient of AB should be equal to the gradient of BC, should be equal to the gradient of AC. So here there are many equations that you can use, many pathways that you can create. If you want, you can just collect these two. If you prove that the gradient of AB is equal to the gradient of BC, then the lines are collinear. If you want, you can just get these two. If you prove to say that the gradient of BC is equal to the gradient of AC, then the points are collinear. Or if you want, you can just get the gradient of AB and prove whether or not it is equal to the gradient of AC. If they are going to be the same, then again, the points are going to be collinear. Okay? So let us handle it in this way. Let us prove if the gradient of AB is equal to the gradient of BC. Let us take this first portion. So the gradient of AB is going to be in this way. Remember, having seen that it's A and B, we're talking about A is -1, -1, B is 0,1. So this is going to be y2 minus y1 over x2 minus x1. If you're using A and your B, then this is going to be your x1, y1, x2, y2, right? So your y2 is just simply going to be 1 minus, now remember your y1 is having a negative 1, so you open your brackets, then you put your negative 1 like that. x2, 0, minus, it's part of the formula. Again, we're having a negative 1. Negative times negative, that's positive. So it's going to be 1 plus 1. Negative times negative, positive. So it's going to be 0 plus 1. 1 plus 1 is 2. 0 plus 1 is 1. And 2 divided by 1, the answer is going to be 2. Let us see if that is going to be equal to the gradient of BC. 0, 1. Your C point is 2, 5. So let us try to determine the gradient of BC. Same thing, y2 minus y1 over x2 minus x1. This is going to be x1, y1. This is going to be x2. This is going to be y2. So this is going to be 5. 5 minus 1 over your x2 is 2 minus 0. 5 minus 1, the answer is just going to give you positive 4. 2 minus 0, the answer is just going to be positive 2. 4 divided by 2, the answer is going to be 2. Have you seen? The gradient of AB is equal to the gradient of BC. So due to that, you can make a conclusion to say that MA, the gradient of AB, is equal to the gradient of BC. Thus, the points A, B, and C are collinear. And that's it. That's how we handle such problems like this. But someone can ask to say that, what about AC? Is the gradient the same? Well, let's prove. Let us try to determine the gradient of AC. A is negative 1, negative 1. That's A. Your C is 2, 5. Again, this is going to be your x1, y1, x2, y2. Again, 5 minus negative 1 over 2 minus negative 1. Remember, negative times negative, that's positive, so 5 plus 1, 2 plus 1. 5 plus 1, this is going to be 6. 2 plus 1, this is going to be 3. 6 divided by 3, the answer is just going to be 2 again. So if you wanted to, you'd have just said that the gradient of BC is equal to the gradient of AC. Thus the points A, B, and C are collinear. So there are many options that you would have taken. If you want, you'd have proven that AB, that's a poor M, is equal to the gradient of BC. If you want, you'd have said that the gradient of AB is equal to the gradient of AC. Yeah, AC. If you wanted to, it would have worked. Or if you want, you would have said that the gradient of BC should be equal to the gradient of AC. Whether you go in this way, or this way, the fact that the gradients are the same and they are involving all the 3 points A, B, and C is evidence enough that these points indeed are collinear. So that's how you can determine collinear points. Thank you very much.